Have you ever stared up at the night sky on a perfectly clear, freezing winter night and felt that sudden, sinking sense of existential dread? You look at all those brilliant, burning stars, and you suddenly remember what standard science tells us about the end of the story. The grand finale isn't a spectacular explosion or a triumphant cinematic climax. It is, quite frankly, the ultimate cosmic buzzkill. We are told it all ends in the Big Freeze. A completely cold, unimaginably dark, and infinitely lonely void where every single star has exhausted its fuel. The engines of the cosmos grind to a halt, and the very clock of time simply stops ticking. It is a terrifying thought.
It really is the bleakest possible narrative you could write for reality. For decades, that has been the accepted orthodoxy in cosmology. We call it the heat death of the universe. The idea is that everything is slowly winding down, radiating its energy away into an ever-expanding abyss until there is absolutely nothing left but a frigid, lifeless equilibrium. But what if we have been looking at this entirely the wrong way? What if the universe isn't actually dying at all? What if, instead of expiring, it is merely preparing to go into a very deep, very necessary sleep?
A cosmic slumber. That completely flips the script. And that brings us to the core of what we are unpacking today. There is a radical, almost poetic new framework emerging in physics called Defreeze cosmology. It is a theory that challenges the very foundation of the heat death. It suggests that the universe never actually forgets who it was, what it built, or what happened here. Instead of a final, fatal freeze, this theory proposes that the end of our universe is actually just a cosmic reset button.
Exactly. To really appreciate how revolutionary this defreeze concept is, we have to first understand the prison that classical physics put us in. The warden of that prison is the second law of thermodynamics. It is a rule we experience every single day. It states that entropy, which is essentially a measure of disorder or chaos, must always increase in a closed system.
The classic sandcastle analogy comes to mind here. You spend hours on the beach, meticulously building this beautiful, highly structured sandcastle. It has towers, a moat, little windows. But then you leave it alone. The wind picks up, the tide rolls in, and over time, that highly organized structure is battered and blown away until it is just a flat, featureless pile of sand. Conventional wisdom tells us that once it becomes that flat pile, the castle is gone forever. The structure is lost, and more importantly, the information of that castle is destroyed.
That is precisely the assumption that Defreeze cosmology attacks. The Big Freeze theory assumes that when we can no longer perceive structure, when the stars burn out and the galaxies dissolve into a uniform soup of cold particles, all the information that made up those stars, those galaxies, and even us, is permanently annihilated. But there is a massive scientific gap in that assumption, and it comes from the world of quantum mechanics. Quantum physics operates on a non-negotiable rule called unitarity.
Unitarity. That sounds like a strict cosmic accounting system.
That is a brilliant way to put it. Unitarity demands that information in a quantum system must be conserved. It cannot be created from nothing, and it absolutely cannot be destroyed. So if thermodynamics says the sandcastle's information is lost to the wind, but quantum mechanics says information is indestructible, we have a massive contradiction.
And this forces us to redefine what we mean by information. When most people hear that word, they think of data on a hard drive, a Wikipedia article, or a text message. But in modern physics, information isn't an abstract concept. It is a physical quantity. It is as real and fundamental as energy or matter.
It is the bedrock of reality. Every particle's spin, its position, its velocity, its relationship to other particles. That is all physical information. Think of the universe not as a giant machine, but as an infinite, sprawling library. Now imagine you are in this magnificent library filled with the history of everything that has ever existed. Suddenly the power goes out. The lights shut off. You are standing in pitch blackness. You cannot see the books, you cannot read the pages, and you cannot navigate the aisles.
But the books didn't cease to exist just because the lights went out.
Precisely. The information is still there, perfectly printed on the pages. The library is intact. What you have lost is simply the flashlight, the usable energy required to read them. The heat death isn't the destruction of the library, it is just the lights going out. This isn't just philosophical speculation either, it is backed by something called the quantum Liouville theorem, which essentially proves that in a closed system, the total amount of quantum information remains perfectly constant forever.
So, the universe is a library in the dark. That is a comforting thought, but it raises a massive logistical question. If everything is freezing, expanding, and dissolving into essentially nothingness, where exactly is this library? Where does the universe store all this indestructible information when the physical structures we recognize have completely evaporated? Defreeze cosmology points to something called the quantum vacuum, right?
Yes, and this is where the physics gets incredibly strange and beautiful. When we think of a vacuum, we think of empty space, a void, nothing. But in quantum field theory, empty space is anything but empty. It is a boiling, hyperactive grid of potential. Defreeze cosmology suggests that during the heat death, all the information of the universe hides in this quantum vacuum.
It is like a frozen hard drive. Imagine a computer that has been unplugged and left in a freezing room. The screen is black, the fan is silent, the machine appears completely dead. But if you take a microscope to the magnetic platters of the hard drive inside, the ones and zeros, the bits of data, are still physically etched into the disk. The universe's hard drive is the vacuum of space itself.
That is a perfect translation of the mathematics. Even in what we perceive as completely empty, dead space, there is something called zero-point energy. There are these underlying fundamental vibrations known as identity stem waves. For a long time, physicists just viewed this as background noise, the static of the cosmos. But Defreeze cosmology flips that perspective. This isn't random static. This is a highly complex, infinitely dense memory structure. The vacuum is preserving the quantum correlations of literally everything that has ever happened.
It is holding the memory of every supernova, every black hole collision, every ocean wave that ever crashed on Earth, and every thought we ever had. It is all etched into the frost of the vacuum. That completely changes how we view the end of time. It means the heat death isn't a graveyard. It is a state of dormancy. It is hibernation.
Hibernation is the exact right word. The universe reaches a state of what physicists call entropy saturation. It has maximized its disorder, it has cooled down, and it goes to sleep. But here is the critical pivot in the theory. Dormancy implies an eventual awakening. Defreeze cosmology proposes that this frozen dark state is not eternally stable. Eventually, a long-term instability begins to ripple through the vacuum.
Like a thaw after an unimaginably long, brutal winter.
Yes. Think about a frozen landscape. For months, everything is locked in ice. Nothing moves, nothing grows, it looks entirely dead. But the seeds from the previous summer are still buried in the frozen soil. They haven't been destroyed, they are just waiting. When the temperature shifts, when a specific threshold is crossed, the ice begins to melt. The water flows, the soil warms, and those dormant seeds suddenly reactivate. They begin to grow again.
So the universe experiences a cosmic spring. That long-term instability in the vacuum is the temperature shifting. And when that happens, this theory suggests the universe undergoes a defreeze transition. It takes all that stored information, all those buried seeds, and reactivates them. This leads to a new expansion, a new dawn. It is what some physicists might call a non-singular bounce. Instead of everything crushing down into an infinitely dense point, a singularity, and destroying all data, the universe just bounces back into action.
Exactly. The clock doesn't smash into pieces and disappear. It just winds itself back up using the latent energy and information stored in the vacuum. It is a seamless transition from one epoch of reality to the next, entirely avoiding the mathematical nightmare of a singularity where our laws of physics break down.
But this brings up a fascinating, almost philosophical dilemma. If the universe thaws out and restarts, using the exact same information from our current universe, does that mean the next universe will be exactly like this one? Are we just going to sit here in another 15 billion years having this exact same conversation?
That is the most profound question this theory invites. And the answer is no, it won't necessarily be identical. To understand why, we have to separate the concept of information from the concept of physical laws.
Okay, let's break that down. I like to think of it through a musical analogy. Imagine that the fundamental information of our universe, all the quantum data stored in the vacuum, is a magnificent musical score. It is a symphony written on paper. The laws of physics, on the other hand, are the instrument used to play that score.
That is a beautiful way to frame it. The score, the raw, foundational information of everything we are, survives the Great Freeze and the Great Thaw. It crosses the boundary into the new universe. But in this new cycle, the underlying conditions might have shifted. The effective laws of physics might manifest differently.
So, in our current universe, the symphony is being played on a grand piano. We know the sound, we know the resonance of gravity, the specific speed of light, the exact mass of an electron. But after the defreeze, that exact same sheet of music is handed to a new universe, and this time, the instrument is a violin.
Exactly. The music will sound entirely different. Maybe in the next universe, gravity is overwhelmingly strong, or light moves at a fraction of its current speed. Maybe the spatial dimensions are altered. The physical manifestation, the sound of the universe, will be completely alien to us. But the melody, the underlying mathematical truth, and the quantum correlations remain exactly the same.
It is an information lineage, a cosmic heredity. The physical bodies of the universes change, but the soul, the data, is passed down through eternity.
And that solves one of the biggest, most persistent headaches in theoretical physics, the information paradox. For decades, we have been terrified by the math that suggested reality was actively deleting its own history. If information could be truly destroyed, it meant that the universe was fundamentally chaotic, random, and ultimately meaningless.
It would mean that time itself is fractured, that there is an absolute end, a hard wall where the story just burns in the incinerator.
But Defreeze cosmology elegantly repairs that fracture. It tells us that time is entirely continuous. The clock doesn't just stop and melt away. It keeps ticking, perhaps in a hidden quantum mechanical way that we cannot currently perceive, but it ticks nonetheless.
It gives a profound sense of permanence to our fleeting existence. It tells us that the universe actually remembers every struggle, every triumph, every civilization that rises and falls. It isn't just a random accident destined to be wiped clean by the cold. We are literally writing the code for the next iteration of reality. We are a chapter in an eternal, unbroken story.
It shifts our perspective from existential despair to a kind of cosmic responsibility. The things that happen here, the structures that form, the information we generate, it all gets woven into the zero-point energy of the vacuum. It becomes the foundational architecture for whatever comes next.
It is incredibly humbling. We spend so much time worrying about legacy, about leaving a mark on the world before we are gone. But physics is telling us that our mark is indelible. The universe is the ultimate archivist. It never throws anything away.
It just files it in the dark for a while. It is a comforting thought, really. The heat death isn't a tragedy. It is just the universe taking a deep breath, resting its eyes, and letting the stage cool down before the curtain rises again.
So, the next time you step outside on a freezing night and you look up at that vast, dark expanse, you don't need to feel that chill of dread. You don't need to worry about the cold, lonely end of everything, because the void isn't empty. It is brimming with memory. The universe is just quietly saving its data, resting in the frost, patiently preparing for the next big performance.